Welcome to queen7.com. Please like, share and subscribe my video. Today we're going to learn about the reaction profiles. In the previous video you have learned what is exothermic and endothermic reactions. Exo means out and endo means in. Out and in means the system either gonna lose energy, which means out, and in means the system is actually gaining energy. And examples are, for example, exothermic reaction when energy goes out, and one of the example is respiration. In respiration, you inhale oxygen, and then you have obviously glucose from your food, which is going to combine in your cells, produce water, carbon dioxide, and energy for your cells. And same goes for the endothermic reaction, where you will have photosynthesis. Photosynthesis is actually the opposite of the respiration. So it happens in the plants where they absorb the carbon dioxide, they actually get the water from the roots, and then they will actually absorb energy from the sunlight, and then they will convert into a sugar which we use, and then they produce oxygen as well. So they both are actually the opposite of each other. Now, based on this one, how are we going to represent in terms of the reaction profile? Now, for example, if in exam they probably want to ask you that can you actually draw a reaction profile of methane gas producing carbon dioxide and water. Now, you do know that when you burn something, you produce energy. So what's going to happen is they have the energy, and the product will actually be made along with some energy which will be lost. Now you have the thermometer which actually tells you the temperature is rising. So the system means the test tube, the container where you're doing the chemical reaction, should get warm or hotter, and in order to show you that the temperature is rising. Now in this case, when you burn methane gas with oxygen, it will produce carbon dioxide plus water and plus energy. Now that is the energy we use. Now what's going to happen is I am going to represent that because the energy is produced on the reactant side, the product side, the product has, if this is energy on y-axis and this is the time or reaction progress, these are the products. Now in this equation in chemistry, anything on the right hand side is product, anything on the left hand side is a reactant. Now in this case, these are the products. So I will write down CO2 plus H2O. So these are the products. Now products have low energy and the reactants have high energy. Reactants are actually CH4 plus O2. Now two things you need to actually learn. One, activation energy. Second, you need to learn about the difference of energy between reactants and the product in reaction profile. Now, when you have the reactants, if you mix methane gas and oxygen, you sit all day, nothing's going to happen. So what you have to do, you have to provide them some sort of activation energy, which will actually make them aggressive, so they can actually bump into each other with the successful collision, and they can start the chemical reaction. So what's going to happen is CH4 and O2 are rather going straight into the product. Even the product has got low energy, you have to provide them some sort of energy first. So up to there, you have to provide them some energy, and on their top of the curve, before it started converting the product, it has to gain that sort of energy. Now in this chapter, please do remember, if they ask you to draw and label that activation energy, you need to remember one thing: it will always be from the reactant to the top of the curve. It doesn't matter if it's endothermic or exothermic. So this is reactant energy. So this is the level of the reactant energy. So you will draw a dotted line there all the way up to there, and you will label it as activation energy. Now if they ask you, now your reactant has high energy, your product has low energy, so the difference of energy between them, which can be drawn like that, is called delta H. In mathematics, delta means change. So that shows you the product has low energy. Now there are two things you can do to remember how you're going to do that. In question, either they will say this is the chemical reaction, draw a reaction profile, and it is actually an exothermic reaction. If they use the word exothermic, means energy is out, your product will actually have the lower energy than the reactant. But if they do not mention that and they say that the rather writing down exothermic or energy, they will say, oh, delta H is equal to, sorry, I'm going to write it there, minus 110 kilojoules per mole. Just for example, this minus sign tells you that it is an exothermic reaction. Because system has lost the energy, that's why we call that energy as negative, because system doesn't have that energy anymore. Now after this, once you're done, you can actually draw the same kind of reaction for the other side. For example, if you have a ethanoic acid or calcium carbonate, CaCO3, you're converting a CO2 plus H2O. If you want to convert CaCO3 for the decomposition, you have to give some energy to calcium carbonate to convert into carbon dioxide and water. If they say this is an endothermic reaction, fine. If they don't say that, then they might will say delta H is a positive value, or they will give you a positive value. So both ways you can actually predict this is an endothermic reaction. Now I'm going to draw the reaction profile. So this is actually the energy, this is the time, this can be in seconds or minutes. Now we're going to start the reaction. Because energy actually put it into the reaction, what's going to happen is that the reactants has low energy. It is why you have actually put the energy in the system. Then you have the products which are made because reactants absorb that energy and convert into carbon dioxide and water. So that will go like that. So it's not going to convert into product straight away. It has to go a little bit higher than the energy of the product and then started converting at this point, and that is called the activation energy. And I'm going to write down the definition in the bottom in a minute. Activation energy is the minimum energy required for the reaction to occur. So to start the reaction, to make it happen, you have to have some sort of minimum energy which should be higher than the energy of the reactants or the products. Now this is the reactant. Anything on the left hand side will be called as reactant. So CaCO3 is the reactant, and products are CO2 plus H2O. Once you have made that, I have told you the activation energy is actually starts from the top of the curve all the way to the reactants, because product doesn't have, it has got nothing to do with the activation energy. So what you need to do is you draw it and all the way down, and there you go. So this one will be known as activation energy. And after this, what is the difference of energy between the reactants and product? If they ask you to actually do that, you can draw a dotted line all the way to the same here, and that will be delta H. Because you have actually put the energy in the system, you have actually heated the reaction mixture. So that means energy has gone down into the system, from the surrounding into the system, in your test tube, in your beaker. So it will be positive value. So if you will see a positive value like that, you can actually draw it. Either they will say it's endothermic, it is then you're going to draw it, or they will give you a positive value. That is another identification of endothermic reaction. Now I'm just going to write down in the bottom the minimum energy required for the reaction to occur. So the sports injury pack is one of the example which are actually endothermic, which actually absorb the energy, which can help you to reduce the pain. Please wait for the next video as well. It's going to be on the bond enthalpy. Thank you very much.